Hi, everybody. So I have a last few things that I want to kind of tie things up with on Chapter 13. And some of it has to do with the lecture that you just watched. All right, so just a few things. Let's go ahead and get busy here. So last couple things on colligative properties. And I want to quickly talk about what's called Raoult's law. So from last lecture, we know as a solute is added to a solution, our vapor pressure will decrease. And we went all through this. Okay, so this is one of our colligative properties. But what this law does, it actually lets us to calculate the new vapor pressure. Okay, so this law lets us calculate the new vapor pressure. All right, and it's just a formula. All right, so the partial pressure, or the change in pressure, is equal to the mole fraction of the solvent. Okay, remember mole fraction is chi times vapor pressure. Okay, so this is just allowing us to calculate that new vapor pressure. Right? And I want to do a problem, and it's kind of long, so I'm going to kind of flip over here to the next page. So here we go. Glycerin, which is C3H8O3, is a non-volatile non-electrolyte with a density of 1.26 grams per milliliter at 25.0 degrees C. Calculate the vapor pressure at 25 degrees C of a solution made by adding 50.0 milliliters of glycerin to 500.0 milliliters of water the vapor pressure of water at 25 degrees C is 23.8 torr, and its density is 1.00 grams per milliliter. Now that's a long, wordy problem. All right, so really what we're doing is trying to calculate that new vapor pressure. So we're going to be using Raoult's law. All right, so eventually we need our partial pressure is equal to our mole fraction times our vapor pressure. All right, so we're going to be calculating this new pressure. We know our original vapor pressure, there it is, we have to figure out chi of our solution, which means we need moles. All right, so we're going to need moles. Well, the question is, how are we going to get there? Well, it's giving us some densities. All right, so we know density equals mass over volume. All right, and then we're going to have to get into moles. So we're going to need moles of H2O, okay, and moles of glycerin, and that gives us our, then we can actually calculate our mole fraction. All right, so let's start with H2O. All right, so we know that density equals mass over volume, and we know the density of water is 1.00 grams per milliliter. That'll let us calculate our mass because we know our volume is 500 milliliters. So when we cross multiply, it turns out we have 500.0 grams of water. Now we can convert that to moles. Number of moles equals given mass over gram formula mass. Okay, we have 500 grams. GFM of water is 18.0 grams per mole. So it turns out that we have 27.8 moles of H2O. All right, well, that's fine and dandy. And now we really need to do the same thing with our glycerin. So density equals mass over volume. Our density this time is 1.26 grams per milliliter. Okay, trying to figure out our mass, and we have 50.0 milliliters. We do that math, and we get 63.0 grams. Okay, now we can convert to moles. Number of moles equals given mass over gram formula mass. Our given mass is 63.0 grams. Okay, I'm going to give you the GFM, or the molar mass of this guy, at 92.1 grams per mole. I mean, we can calculate that, but at this point you should be able to do that. And it turns out that we only have 0.684 moles of C3H8O3 of our glycerin. Right. Well, now that we have these, we're almost ready for this. Okay, so we have to do our mole fraction. Right, now our mole fraction, remember, is the part over the total moles. Right, now remember, we're dealing with vapor pressure of water, so our part is our water. Right, so our chi is going to equal 27.8 all over total, which is 27.8 plus 0.684. Okay, so our chi is, what is our chi? 28.5-ish. Okay. All right, so now that we have chi, we can actually substitute into the formula. So our partial pressure is equal to our chi times our vapor pressure. And you can do this any sort of way. You can put it in this way. 27.8 over 27.8 plus 0.684 times our vapor pressure of 23.8 torr. Right? And when we do that math, our partial pressure, or the vapor pressure of the water, is reduced to 23.2 torr. Okay. So actually just a nice simple way to come up with that new vapor pressure using the mole fraction. All right, so that has to do with our vapor pressure. There's only one little thing that I want to talk about with our boiling point elevation and our freezing point depression. Okay, and it's just identifying one of the variables that I didn't identify in the last video. All right, so we're talking about our boiling point elevation and our freezing point depression. Okay, our formula for this is delta TB, our change in temperature equals I kBm. Right, and for freezing point, it's the change in temperature of our freezing point equals negative I kFm. Right, now, okay, so this is our change in our boiling point and our freezing point. Right, we know that M is molality. Okay, and these are our Kb and Kf are our constants. Right, this I, and we talked about what this I is, but it has a name. Okay, so this I is called the Van Hoff factor. And all that Van Hoff factor is the number of fragments that a solute breaks into for a particular solvent. And we went through this. We just didn't name it the Van Hoff factor. So for example, NaCl. Okay, so when we take our NaCl solid and we dissolve it in H2O, it breaks up because of that molecule ion attraction, and we get Na plus and Cl minus aqueous. So for every one of these, we get two of these. Well, our Van Hoff factor, or our I, would equal 2. All right. So all I'm doing here is I'm just identifying what that I is for you. Okay, it's that Van Hoff factor. All right. Now, the last thing that I want to talk about are colloids. And I'm not going to spend a ton of time with colloids. These are also called colloid dispersions. And there's a lot we could do with colloids, but I don't think we need to. It goes into a little bit more depth in the textbook. But there are really just some specific things that they're hydrophilic and hydrophobic colloids and all that kind of stuff, and I'm really not interested in going there. So I just want you to understand what a colloid is and some specific things about them and maybe some examples. All right, so a colloid or colloid dispersions are substances that appear to dissolve in a solvent, but over time will separate. They kind of look like homogeneous solutions to start. Okay, they look like homogeneous solutions. They're kind of the dividing line between a solution and a homogeneous mixture. So colloid. Okay, have you ever taken, I don't know, maybe gone to a river or something, and you pull up, a glass full of water from a river, and you look at it, and it looks brown. All right. Well, the reason it looks brown is that there's usually clay or particles or soil particles in that water. All right, and it looks like it's homogeneous. All right, but if you let that water sit over time, right, those tiny clay particles are going to settle to the bottom and it's going to be clear. That's kind of an example of a colloid. Right? Another thing that you could do, if you want to do this at home, it would be kind of cool. If you take water and add cornstarch, Okay, do this if you can. All right, so get a glass, add some water. Okay, just get a glass, add some water, and then stick some cornstarch in and mix it up. And this is going to look cloudy. Okay, and it looks like the cornstarch actually dissolves in the water, and you don't need a lot of cornstarch to do it. All right, but this actually is not a homogeneous mixture or a solution because it's going to separate over time. All right, it looks cloudy, right? But this is what's called a colloid dispersion, right? So this is something that you can actually do right at home if you have some cornstarch. Number 3, so these are often cloudy or opaque. And because of this, colloidal particles disperse light. And this dispersing of light is called the Tyndall effect. Now, you've seen this Tyndall effect before. Okay, so for example, if I do this, if we were in class, I would do this in class for you. So if we were to take a laser, all right, and I press the button like a laser pointer, and I press the button, all right, the laser light would go through the air and would strike the wall, and we could see the dot on the wall. But you can't see the light as it's traveling through the solution of air, all right, because the light is not being dispersed. But if I take some erasers and I clap chalk all the way in the air down the laser line, okay, that chalk dust is actually a colloid. All right, and the chalk dust itself actually reflects or disperses that light, and then you can see the laser line all the way through the air until it hits the wall. Okay, so that's what I mean by dispersion of light, and that's what the Tyndall effect is. And our colloids, okay, will disperse this light, and we will be able to see that Tyndall effect. Okay. Now, our colloids can be all 3 phases: gases, liquids, or solids. Okay. And I just want to give you some examples. An aerosol. Okay, oops, that's an L. An aerosol. Okay. This is when a liquid is dispersed in a gas. Perfect example of an aerosol, all right, is when you use your bathroom spray. Okay, and that spray that comes out of the can is a liquid, all right, but it disperses into our air, all right, and it's actually a colloid. Okay, so aerosols are an example of a colloid. Foam. Okay, so this is when gas is dispersed in a liquid. And an example of a foam would be whipping cream. When we make whipping cream, we take that heavy cream, okay, and we beat it. And what we're doing is we're adding air, okay, we're adding air into that liquid, and it actually is a colloid. Okay, it's a colloid. Okay, so a foam is an example of another colloid. Emulsions. Okay, this is when liquids are dispersed in liquids. And an emulsion, an example of this would be milk. Okay, milk, it's actually a colloid. It's a suspension. Okay. And then the last one I'm going to talk about is a sol, and there are different types. All right, but the biggest sol is when we have a solid dispersed in a liquid. And these are paints. Okay, these are paints. All right, so these are all some examples of colloids. So that finishes up Unit 4 in Chapter 13. Make sure you watch some of the additional videos that I've put up, right? So you kind of adds to some of these things. And we will see you soon.